In 10.1, we're learning about square root functions. We are going to graph and analyze dilations, reflections, and translations of radical functions. So this should be similar to things that we've already done with transformations of parabolas, lines, and exponential functions. A square root function is a square root is the same thing as a radical with an index of 2, but the parent function just looks like that. A radical function could be a square root or a cube root or anything with a radical, but we're only doing square root functions. The radicand is the number inside the radical. This is just a picture of the parent function. You'll see that the domain and the range are both greater than 0. So this is what you do to graph it. I'm going to plug in numbers for x to find y. All right, so if I say it says graph f of x equals 2 times the square root of x. Notice I said times the square root of x. So I'm going to put numbers in for x to find y. Now realize that when I do it, I'm going to want to make this as easy as possible. So look at what numbers I'm plugging in for x. X is under the radical, right? So I want perfect squares to be able to put under there. So for instance, 2 times the square root of 0, any times the square root of 0 is just 0. 2 times the square root of 1 is 2 times 1, so that's 2. 2 times the square root of 4, the square root of 4 is 2, so 2 times 2 is 4. And 2 times the square root of 9, the square root of 9 is 3, and 2 times 3 is 6. So notice everything that is under the radical, I want to end up being a perfect square. So that way I'm not trying to graph with a lot of variables. So I'm going to plot all these points. So I've plotted all the points, and then I'm just going to connect those with a curved line like that, and that is that function. All right, so you try one exactly like I just did the last one. And remember what you know about transformation. So what does it mean when a number is larger than 1 and in front of the grouping symbol? This works the same way that we just did quadratic functions a little while ago. You should have gotten B. Okay, so we're going to graph f of x equals -1/2 times the square root of x, and then compare it to the parent function and then state the domain and range. So we're going to do it just like we did the last one. I want perfect squares to be under that radical. So my perfect squares would be 0, 1, 4, and 9. Remember, here are your some perfect squares. So 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared. This is what I'm putting in. Okay, so when I say I'm putting in perfect squares, that's the type of numbers that I'm talking about. All right, so -1/2 times the square root of 0 is just 0. -1/2 times the square root of 1 would be -1/2. -1/2 times the square root of 4 would be -1/2 times 2, which would equal -1. And -1/2 times the square root of 9 would be -1/2 times 3, which is -1.5. Okay, so let's plot all those that we can fit on this graph. So I've got 0, 0, 1, -1/2, so that's about right there. 1, 2, 3, 4, and -1. So that's as much as I can fit on this graph, so it looks like that. Now it says also state the domain and range. So the domain, remember, is all the x values. So where is the x starting at? It's starting at 0, and it's greater than or equal to 0. That line is all the numbers where x is greater than or equal to 0. My range is all the y values, and that is also starting at 0, but it's less than 0, so less than or equal to 0. That is my range because that line is dipping down. And then you can see here their prettier version of it. Okay, I want to give you a second, try to do the same thing that I just did and figure out which letter it is. Please use your knowledge of transformations to be able to see. And you should have gotten A because the negative means that is reflected over the x-axis. The 4 is greater than 1, so that shows that it's a vertical stretch. And if you plug in your numbers, you should have gotten 0, 0, and 1, negative 4. Now, just comparing what we know about transformations, what does it usually mean when a number is out on the side all by itself? That usually means it's going up or down. So since we have -1, we know that this means that it is going down by 1. So if I was going to do this, I would say instead of starting at 0, 0, we're going to start at -1. And then I know that it's going to go something like this. Okay, because the parent function, remember, is just like that. So the parent function starts at 0, 0. So all I'm doing in this case is going down 1 and then also doing it. So if it wants my domain, that's all my x values. That's where x is greater than or equal to 0. And my range is all my y values. Now, where am I starting at y? I'm starting where y is -1 and I'm going up. So greater than or equal to -1. This says graph h of x equals the square root of x plus 1 and compare it to the parent graph. State the domain and range. I hope you remember your transformations because when you have a plus or minus inside a grouping symbol, that means to the left or the right. So since this is plus 1, that means that we're going to the left 1. So if I was going to graph this, instead of starting at 0, 0, I would go left 1 and draw my square root function, which means that its domain, instead of x being greater than or equal to 0, I'm starting at -1, and it's all numbers greater than or equal to that. My range, my y value, has not gone up or down, so it's still starting at 0, and it's going up, so it's greater than or equal to 0. All right, I want you to try to do this one. Pause the video and try it. You should have gotten D because since it says +3, that means we're going up 3 units. Okay, pause the video and try this one. And since you have a -4 inside the square root function, that means that you're going to go 4 units to the right. So this problem, it says graph y equals 3 times the square root of x minus 2 and compare it to the parent function, or to the parent graph. State the domain and range. All right, so before we start graphing it, I just want to kind of talk about the transformations that are taking place. So the 3 is in front of the square root function, okay, and in front of the square root sign. So when a number is in front, that means either vertical stretch or vertical compression. And since the number is greater than 1, this would be a vertical stretch. Okay, the -2 is inside the square root sign, so that means it's either going to the right or the left. And if it's -2, it would be going to the right 2. All right, now to graph it, let's see what we can do. Okay, so I'm going to plug in numbers, and on Alex, you're going to have to actually graph these. So I want you to not just know the transformations, but I want you to be able to actually plug the numbers in. Okay, so if I'm plugging in numbers, remember, I want what's underneath my radical to end up being perfect squares. Okay, and this is the part that's most complicated for a lot of people. So what is under the radical, the x minus 2, needs to equal perfect squares. Okay. So what are my perfect squares? I want this to equal 0. I want it to equal 1. I want it to equal 4. And I want it to equal 9. So then what do my x values need to be for that to happen? Add the 2. So 2, 3, 6, and 11. If you need to pause it here, you can. My whole point, though, is to get perfect squares under the radical. So I'm going to put these numbers in. And again, that is always the hardest part for people. So if you're confused right now, it's okay. You can always call me on Teams and ask me about it. Okay, so now I'm going to plug those numbers in and see what I get for y. So I have y equals 3 times, plug in the numbers, so 2 minus 2. So, I'm sorry, 3 times the square root of 0, which would just be 0. Then I'm going to plug in the 3. So 3 minus 2 is 1. The square root of 1 is 1, so I would just get 3 right here. The next one, if I plug in a 6, I would get 4. The square root of 4 is 2, so I get 6. 11 minus 2 is 9, and the square root of 9 is 3. So that's 9. Now I want you to take a second and look at all these. All those numbers are perfect squares. You don't have to do that, but it makes it so much easier to graph when you're not dealing with a bunch of decimals. Okay, so now I am going to plot all those points. Okay, so I've got 2, 0, 3, 3, 6, 6, and 11, 9. So this graph looks like that. And if you kind of compare it with what we originally thought, we thought that it was going to be vertically stretched and right 2, and that does look like what it is. Okay, so the domain, remember, is all my x values. So that it's starting at where x equals 2, and it's going to the right, so it's getting bigger. So x is greater than or equal to 2. And the range is all the y values, so it's starting where y equals 0, and it's going up. So that is your final answer. And this is their version. So it's the same thing. We did a good job. Okay, I want you to try to do this one. So state the domain and range, and I'd also like you to try to graph it. Okay, so the answer is D. If you want to pause the video and look at all my work, you can. You'll see on the right-hand side right here how I got all my values for my table of values. And then I just plugged them in this original function to find all my values for y. I plotted the points and I graphed it. And so my starting point for x is at -4, and I'm going to the right. And my starting point for y is -1, and I'm going up.